Alright, in this video we're going to talk about linear modeling, section 9b. Okay, now we'll talk about what a linear function is. It has a constant rate of change in a straight line graph. A linear function has a constant rate of change and the graph of it will be a straight line. Alright, the rate of change is equal to the slope of that graph. Okay. The greater the rate of change, the steeper the slope. So those two have a relationship here. And to calculate the rate of change by finding the slope between any 2 points on the graph, we use this formula. The rate of change is going to be equal to the slope, and that's also equal to the change in your dependent variable divided by the change in the independent variable. Okay. Now, to find the slope of a line, or to find the slope of a straight line, we look at any 2 points and divide the change in the dependent variable by the change in the independent variable. So here, this is what the graph looks like. We got an independent variable values. That's the horizontal axis. The vertical axis are your dependent variable values here. And here's a straight line with 2 points, point 1 and point 2. In this case, the change in your dependent value will be from this point to here. That's that distance. That'll be divided by the change in the independent variable from that point all the way to here. That distance is your change in independent variable. Okay. So if we look at example 1, here we want to consider the graph to the right. So in words, describe the function shown on the graph. And in part B, find the slope of the graph and express it as a rate of change, and then briefly discuss the conditions under which a linear function is a realistic model for the given equation. Okay. Now in part A, we're going to select the correct answer here. Alright. Now here we're dealing with I think 2 and 1 here. Okay. So if I look at this point and this point here on the graph and look at that particular slope here, the change in the the dependent variable, which is this right here, that's actually, that change is a distance of 1. And then your independent variable, the change in the independent variable from that point to here, that distance there is 2. Okay? So now, the rate of change is going to be this. The 1, the change in your dependent variable, going up and down, over the change of your independent variable, going across. That'd be 2. So in words, according to that function, the ring depth decreases it actually increases by 1 every 2 hours. So it's going to be this answer choice here. Because you see that this line is increasing here, so that means the ring depth is increasing 1 inch for every 2 hours. And then we're going to calculate the slope and represent it as a rate of change. So that rate of change is going to be that 1/2 that I came up with. Now, you will have a choice from a drop-down menu to choose from. Either inches per hour or hours per inch. In this case, we said It's decreasing 1 inch every 2 hours, so it's got to be inches per hour. So it's that answer choice. I'll go ahead and fill this in. And then part C, select the correct answer below. Here I'm going to say that it is a good model if the rainfall is changing or constant for 2 hours and then changing for 2 hours. So I'll pick this one. Okay. Okay. Alright, here's the next example. Here's another graph that looks like this. In words, describe the function shown on the graph on the right. Okay, so let's look at this here. I'm going to compare this point with this point down here at 5. You can see it's going to be decreasing because the line is falling from left to right. As you can see, it is declining. Okay, because at 5, the distance is 0. And at 0, the distance is 200. So we know, in this case here, according to that function, the distance from home decreases by 200 miles every 5 hours. It's decreasing because the line is decreasing. So from 0 to 5, that distance is decreasing every 200 miles per 5 hours. And then calculate the slope and represent it as a rate of change. Well, if it's decreasing, we have to say that it is negative. 200 divided by 5 will be 40. So the rate of change is decreasing by 40, so it's going to be negative 40, and we're dealing with miles per hour. Or we could be dealing with hours per mile, but in this case it's miles per hour. So it'll be 40 miles per hour. And then select the correct answer below. Okay, in this case here, if it's constant for 5 hours, then it would be a good model. Okay. So I choose that particular answer. And I might need to go back to example 1. 1. Okay. Instead of this one, it will have to be that is a good model if the rainfall is constant for 4 hours. Okay. So it's going to be similar to this one right here that I did in example 2. If it's a good model, if the speed is constant for 5 hours, then it will be a good model for this. Okay, next example. Consider the graph to the right that relates a person's height to their shoe size. So in part A, in words, describe the function shown on the graph. Okay. Now, in this case here, they're dealing with 9 and 80. So if I look at this point right here, which is, of course, 0, 1, and at 80, that point there, that point right there has a shoe size of 10. Okay? Now notice it's not starting at 0, so the change in the dependent variable is not going to be 10, it's actually going to be 9, because here it's at 10, this point is at 1. 10 minus 1 will give you 9. Okay, and then my independent variable starts from 0 to 80. So the 80 minus 0, which would be 80. So based on that function, the shoe size will, and since this line is increasing, going upward, it's going to increase by 9 inches for every 80 inches. So it's going to be this answer choice right here. And then part B is to calculate the slope and represent it as a rate of change. And they want you to round this up to 4 decimal places. So here, if we do 9 divided by 80 in the calculator, to 4 decimal places, it's going to be exactly 0.1125. So that rate of change is going to be 0.1125. Now, that's the numerator is the size, and the shoe size, and then the denominator is going to be your height in inches. So we're dealing with size per inch. And again, you'll be given a drop-down menu to choose the correct answer. Size per inch. And then select the correct answer below. Okay, and you're going to have to choose which one would work here for this particular situation here. So the model there, it all depends. The model could be very accurate. Okay. Okay, next we'll talk about the rate of change rule. The rate of change rule allows us to calculate the change in the dependent variable from the change in the independent variable. So here the change in your dependent variable will be the rate of change multiplied by the change in your independent variable. So in this case here, in example 4, the following situation involves a rate of change that is constant. Write a statement that describes how one variable changes with respect to the other. Give the rate of change numerically with units and use the rate of change rule to answer any questions. Alright, in this case here, the water depth in a lake decreases at a rate of 7 inches per week because of evaporation. How much does the water depth changes in 7 weeks and in 13 weeks? Okay. Now, which statement describes this situation here? Well, we know it's decreasing, so that rate of change has to be negative. Okay? So it's going to be negative 7 inches per week. So here we have to choose this first answer choice right here. The water depth varies with respect to time with a rate of change of negative 7 inches per week. Okay. And how much has the water depth changed after 7 weeks? Okay. Well, in this case, after 7 weeks, we know we got the rate of change of 7 inches per week. That's going to be multiplied by the number of weeks after 7 weeks. Now, in this case here, your weeks are going to divide out, and then we multiply 7 times 7, which will be 49 inches. So the water depth has, and in this case, it's decreased, so that means this has to be negative. That 49 inches has to be negative as well. But we can say in the answer the water depth has decreased. By, we just say 49 inches without the negative. And then how much has the water depth changed after 13 weeks? Well, it's decreasing at a rate of 7 inches per week. That's going to be multiplied by 13 weeks. So in this case here, your weeks divide out. 7 times 13 would be 91. And it'd be 91 inches. 91 inches. So the water depth again has decreased because it's decreasing at a rate of 7 inches per week. For 13 weeks, it's decreased by 91 inches. Okay, here's another example. Let me bring this down. Example 5. The following situation involves a rate of change that is constant. Write a statement that describes how one variable changes with respect to the other. Give the rate of change numerically with units, and use the rate of change rule to answer any questions. Here you run along a path at a constant speed of 2.9 miles per hour. How far do you travel in 1.3 hours and in 3.9 hours? Right here, the distance that you travel will vary with respect to time with a rate of 2.9 miles per hour. So in this case here, we're going to pick this choice right here. The distance that you travel will vary with respect to time, and the rate there is 2.9 miles per hour. Now we want to find the distance traveled after 1.3 hours. We're going at a rate of 2.9 miles per hour. And this is going for 1.3 hours. So we're going to multiply that rate times the time. That's how we find the distance. Distance is always going to be rate multiplied by the time. And as you can see, those hours divide out. And we're going to multiply 2.9 times 1.3. This will give you 3.77. And we're going to type in the decimal as is. Yeah, that's what they want. 3.77 hours. Miles. And then what's the distance traveled after 3.9 hours? Now we're going at a rate of 2.9 miles per hour. This time we're going to multiply that by the 3.9 hours that we run along that path. And here again the hours divide out. So if we do 2.9 times 3.9, you'll get 11.31 miles. That means the distance traveled will be 11.31 miles. Okay, let's talk about the general form for a linear equation. General equation of a linear function, I should say. The general equation of a linear function would be the dependent variable equaling to the initial value plus the rate of change times the independent variable. Now, algebraically speaking, will be this. In algebra, x is commonly used for the independent variable and y for the dependent variable. For a straight line, the slope is usually denoted by m, and the initial value, or the y-intercept, is denoted by b. With these symbols, the equation for a linear function becomes y equals mx plus b. Your m is going to be the slope, the b is going to be the y-intercept. And that y-intercept is going to usually be the point where the graph crosses the y-axis if you were to graph a linear function. Okay. So, let's look at this example here. The following situation can be modeled by a linear function. Write an equation for the linear function and use it to answer the given question. Be sure you clearly identify the independent and dependent variables, then briefly discuss whether the linear model is reasonable for the situation described. Here the price of a particular model car is $23,000 today and rises with time at a constant rate of $960 per year. How much will a new car of this model cost in 3.7 years? Okay. Now here we're going to select the correct choice and fill in the answer box to complete that choice. Now let's think about this for a moment. By looking at it, my independent variable is going to be the time in years. Okay? The dependent variable will be the price, because the price is going to depend upon the amount of time here. So I will choose this one. And then we're going to write a linear function that models that situation. So it's going to be p is equal to something. Okay, the price of that car is going to be $23,000 today. So that's a start with $23,000, and then plus it rises with time at a constant rate of 960. So it'll be 23,000 plus 960 times the time t. That would be the linear function here. Starts at 23,000, then increases at $960 per year. That will be our linear function. Now what will be the price of the car after 3.7 years? Okay. So I'm going to use that p is equal to 23,000 plus 960 times, in this case your t is 3.7 years. That's what t is. So it'll be 960 times 3.7. That would mean P is equal to, in this case, 23,000 plus 960 times 3.7. Here I don't need the parentheses because the calculator will do order of operations by doing the 960 times 3.7 first and then add 23,000 to it. So here this will be $26,552. So the price of the car after 3.7 years will be $26,552. Now, is a linear model reasonable for this situation? Okay. Now, it's unlikely that the price of the car of that same model will increase at a constant rate. So we can say that it's most likely not going to be reasonable here for this situation. Okay, because the price could vary. It could vary a lot, but it's not going to increase at a constant rate. Alright, next example, example 7. Okay. Here the directions are the same as example 6. A snowplow has a maximum speed of 40 miles per hour on a dry highway. Its maximum speed decreases by 0.8 miles per hour for every inch of snow on the highway. According to this model, at what snow depth will the plow be unable to move? Okay, so we need to find out what the independent and the dependent variable will be. Okay, let's look at this. In this case here, looks like the depth of the snow will be your independent variable, and your S, that's going to be the speed. That speed is going to be dependent upon the depth of that snow. So I'm going to choose that one right there. The independent variable is the depth of the snow and in inches, and the dependent variable will be the speed in miles per hour. So now we need a linear function for this. The maximum speed is 40 miles per hour, so we know it's going to be 40. And if it's decreasing at 8 miles per hour, so it's got to be minus. And then minus 0.8 miles per hour would be 0.8 times your D, the depth of the snow. That will be the linear function for that particular situation. Okay, now the next situation is that the snowplow will be unable to move when the snow is how many inches deep? That means if it's unable to move, our distance, our speed will have to be 0. So here, I got S is equal to 40 minus 0.8 times D. I need to move that over a bit. Now here your S is going to be 0, so this S will be substituted with 0 equal to 40 minus, I can say this, 0.8 times D. I can write it like this. And now to solve this equation for D, what I would do to avoid all these negative signs, I would take that minus 0.8D and move that over to the other side. That way I will have, and I'll go ahead and write it out, add 0.8D to both sides. That will mean I will have 0.8D equals to 40. And then to solve this equation for D, we're multiplying by 0.8. We'll divide both sides by 0.8. That will mean D is equal to, now do 40 divided by 0.8 in your calculator, you'll end up with 50. So the snowplow will be unable to move when the snow is 50 inches deep. That's how we solve that equation. Now, is a linear model reasonable for this situation? Okay. It's not, because the plowing rate is unlikely to be constant. So here, it's not going to be a reasonable model for this situation. Okay, here's our next example. Okay, pretty much the directions are the same. The cost of leasing a car is $1,000 for the down payment and processing fee plus $390 per month. For how many months can you lease a car with $3,950? Okay, so here we need to find out what our independent and dependent variable is. The independent variable will be the time that's in months, and your dependent variable will end up being the going to be the amount that you pay. Okay, so it has to be this answer choice here, and then we got to write a linear function that will model that situation here. So here it's going to be P is equal to, now the car is being leased, the cost is $1,000, and then we're paying $390 per month. So we know it's got to be 390 times T, which is your time, plus $1,000. Then you can say 1,000 plus 390T as your linear function. And now we need to find out with $3,950, how many months can we lease the car? And we're going to round down to the nearest integer as needed, or the nearest whole number. And I'm going to use the bottom of this sheet. So the P is going to be the amount paid, which was $3,950. And we want to find out how many months can we lease the car. So if your P, a linear function P is equal to 390T plus 1,000, your P is 3950, we'll place that P with 3950, that's equal to 390T plus 1,000. Now we got a linear equation to solve. So to get 390T by itself, I'm adding 1,000, so I need to subtract 1,000 on both sides. That would mean I'm going to have 2,950 on the left side. That's equal to 390T. And then to solve for T, I'm multiplying it by 390, so I need to divide both sides by 390. That would mean T is equal to, I'm going to do 2,950 divided by 390. Now it says 7.564, but we're rounding down to 7. So T will be equal to 7. So a car can be leased for 7 months with $3,950. Now, is that linear model reasonable for that situation? And in this case, it is. because when you lease a car, or even if you buy a car, you have to put up a down payment and make consistent monthly payments on it. So it's going to be that answer choice there. The linear model is reasonable because buying a car usually consists of a down payment and constant monthly payments. Okay. Alright, the next example. You're going to write an equation for the linear function and use it to answer the given question. Be sure you clearly identify the independent and dependent variables. Is the linear model reasonable for the situation described? Here we can rent time on computers at a local copy center for a $7 setup charge and an additional $2.25 for every 5 minutes. How much time can be rented for $22? Let's see. In this case, the rental cost will be your dependent variable, because that rental cost is going to be dependent upon the number of minutes or the time that you rent for using the computer. So your independent variable will have to be your time in minutes, and the dependent variable will be the rental cost in dollars. And now we got to come up with a linear function for that. So it's got to be R is equal to something. Now, we can't use the $2.25 because that amount is for every 5 minutes. So let's see what that's equal to for a single minute. So if I do $2.25, divide that by 5, I'm going to get, I'll come up with 0.45. So we're talking about 45 cents per minute. Okay. So the R will be 0.45 times T, and then we're going to add to it that $7 setup charge. That will be your linear function. R is equal to 0.45 T plus 7. Now the other part, how much time can be rented for $22? Here your R is going to be 22. And the formula, R is equal to 0.45 T plus 7. And R is 22, we just substitute the R with 22. So I got 22 is equal to 0.45 T plus 7. Now we got an equation that we're going to solve for T. We first subtract 7 on both sides to get 0.45 T by itself. 22 minus 7 will be 15, equal to 0.45 T. And then finally divide both sides by 0.45 to solve for T. So now T is equal to, now here we're going to round to the nearest minute. So here I got to do 15 divided by 0.45. To the nearest minute, it's going to be 33 minutes. So 33 minutes can be rented for $22. Now the linear model is or is not reasonable for this situation. In this case, it is reasonable. Okay? It is reasonable because of the fact that, you know, you're charging, this person or this company is charging you 45 cents per minute, or $2.25 for every 5 minutes. Okay. Next we'll look at creating a linear function from 2 data points. In step number 1, you let x be the independent variable and y be the dependent variable. Find the change in each variable between the two given points and use these changes to calculate the slope or rate of change. And then step number 2 is to substitute the slope, which is your m, and the numerical values of x and y from either point into the equation y equal mx plus b and solve for the y-intercept, which is your b. Then finally, step number 3 is to use the slope and the y-intercept to write the equation in the form y equal mx plus b. Okay. Now in example 10 it says, a motorcycle can be purchased for $8,100 or leased for a down payment of $300 and $270 per month. Find the function that describes how the cost of the lease depends upon time. Assuming that the monthly payments are made, how long can the motorcycle be leased before more than the purchase price has been paid? Okay. Now it can be leased for a down payment of $300 here. So we got P already there equal to the $300 down payment and $270 per month. Here T is going to be the time in months, so we're going to add 270 times T. That will be the function that models the situation. P is equal to 300 plus 270 times T. Now we want to find out how long can the motorcycle be leased before more than the purchase price has been paid. Okay? The purchase price is $8,100. So here, that's going to be your P, 8,100. P is equal to 8,100. And the formula P is equal to 300 plus 270T. And that P is 8,100, so we'll substitute that with 8,100. That's going to be equal to 300 plus 270T. So now we want to solve for T. We want to find out how long can that motorcycle be leased before more than that purchase price will be paid. Alright, let's move the 300 over by subtracting 300 to get 270T by itself. This will give you 7,800 is equal to 270T. And to solve for T, we divide by 270 on both sides. I think they want this rounded down to the nearest number, or to the nearest whole number, rounded down. So 7,800 divided by 270 says 28.888, repeating, but we're going to round down to 28. Because they asked us to round down to the nearest integer. So, it would take 28 months before more than the purchase price would be paid for that person to lease that motorcycle. Okay. Let's say we had this. A campus Republicans fundraiser offers raffle tickets for $8 each. The prize for the raffle is a $300 television set, which must be purchased with the proceeds from the ticket sales. Find the function that gives the profit loss for the raffle as it varies with the number of tickets sold. How many tickets must be sold for the ticket sales to equal the cost of the prize? Okay. So here we need to find out what that equation is going to be. Your P is going to be the profit in dollars, and T is the number of tickets sold. So we know it's got to be P is equal to, the raffle tickets are $8 each, so that's going to be 8 times T. That's going to be the number of tickets. Now the prize for that raffle is a $300 television set. Has to be purchased with the proceeds from the ticket sales. So minus 300. Okay, we got to subtract 300 from the proceeds from those ticket sales. That will be your equation to model that function. P is equal to 8 times T minus 300. And then we want to find out how many tickets must be sold for the ticket sales to equal the cost of the prize. In other words, we want our profit to be 0. Because P is going to be the profit in dollars, so the profit has to be 0 if the ticket sales equal the cost of the prize. That means no money, no profit. So I'm going to substitute the P here with 0, so this will be 0 is equal to, I'm going to say 8 times 2, I'll say 8T minus 300. Because I teach algebra, so I like writing it that way. Now to get 8T by itself, you're going to add 300 to both sides. So that means 300 is equal to 8T. And then divide both sides by 8. Now here they want us to round up to the nearest whole number as needed. So if I do 300 divided by 8, this will be 37.5, but we're going to round up to 38. So here, 38 tickets has to be sold for the ticket sales to equal the cost of the prize. Okay. Okay, and finally, example 12. That's the last example in this video. The campus Democrats plan to pay a visitor $144 to speak at a fundraiser. Tickets will be sold for $6 apiece. Find a function that gives the profit or loss for the event as it varies with the number of tickets sold. How many people must attend the event for the club to break even? Now here your P is going to be the profit in dollars, N is the number of people. And they already give you the P is equal to. Now, your tickets are $6 each. So it'll be 6 times N. And they're going to pay a visitor $144 from the ticket sales. So it's got to be minus 144. So P is equal to 6N minus 144. Now for the club to break even, how many people must attend the event? To break even, your profit has to be equal to 0 for someone to break even. Okay? Now, formula is that P is equal to 6N minus 144. Your P is going to be 0 because we want to have a break even, meaning no profit. So it'll be 0 is equal to 6N minus 144. And then to get the 6N by itself, we're solving for N. We're going to add 144 to both sides. That would mean 144 is equal to 6N. Divide both sides by 6. In this case, 144 divided by 6, we end up with exactly 24. So, this club needs to sell 24 tickets. Well, actually, for them to break even, 24 people must attend the event in order to break even. Okay? So that completes this particular video on linear modeling. And do feel free to email me if you have any questions about any of the problems. Good luck on the homework.